Freedom. Look at
All right, we are almost starting. Welcome everyone who is here. It's our second week of building on Polkadot, and today we are learning some great things. We are going to start on Ink, building smart contracts with Ink, and it is going to be awesome. It's going to be great. I'm personally excited. All right. We can give it a bit of time and then we get started. We're planning to cover quite a lot, so in a very short time we really want to make sure that yes, we have everything in time. Okay, you're most welcome, Joseph. We are yet to start at exactly 19:10. We are starting off. We hope to cover this within an hour for the start of programming in Ink. Still moving on with our series of building on Polkadot. In case you have some questions, in case you have some things you want to talk about prior to the start of what we have prepared, you're more than welcome to share. Now, other than that, we're just a few minutes to starting our sessions. I personally be just starting of a language, but it is a very deep language. People are building lots of things. I've looked at Aleph Zero building a lot, building front ends that communicate with Ink smart contracts, how Swift and everything it's really amazing. So I hope this series is really going to be something that is going to kickstart many people to build Ink smart contracts, because you can even build your smart contracts on already existing parachains like Aleph Zero, Astar, and many more. Yeah, so just learning you can take it to another level and then become better. Other than that, we are only 3 minutes to officially starting, and it's exciting. Okay. Kaxi, Joseph. Yeah, it's amazing. It's amazing. I guess we are 2 minutes to officially start up, and there's a lot of exciting things. that you're going to be having, and hopefully this can kickstart someone into building smart contracts with ink. In the ecosystem, in the Polkadot ecosystem, and in many more systems. I think ink is applicable in many things, and this is one of them. All right, so it's exactly 10 minutes past 19 on my end, so I think it's the right time to start. So I think this will make it visible. Mainly when you look at smart contracts, you have very many questions. Why Rust for smart contracts? And we are going to just keep viewing some of the fundamental things as we just peruse through. So in case someone has their time, then they can take off some time and then continue learning on their own. But what you should know is that Rust is very light. It's also the community standard, and there is a lot of tooling that has been built around it. For many years, Rust has been taking the lead as one of the best developer languages. But we can look at these points that have been given. Rust is an ideal smart contract language. It's a type safe, memory safe, and free of undefined behavior. Generates small binaries because it doesn't include extra bloat like garbage collector and advanced optimizations and tree shaking. Remove dead code. Okay. Rust ecosystem, you gain from all the support available. Rust has a lot of good tooling because ink follows Rust standards. Tools like Rust FMT, Clippy, and Rust Analyzer already work out of the box. The same goes for code formatting. No overhead, so minimal runtime, safe and efficient, productive. Cargo credits, first class WASM, small size. This is all one of the reasons you could choose Rust to be used for building ink. So why WebAssembly for smart contracts? I'll not just take it, but WebAssembly, we're saying that there is a lot of high performance, small size, general virtual machine and bytecode, efficient, just-in-time execution, minimalistic, deterministic execution. When you go through this, you really find a very good reason on why you should be using ink for your smart contracts. These, I think, most of the people we can go through them ourselves. I'm moving fast so that we can get to the nitty-gritty of building ink smart contracts. So smart contracts in Polkadot, one of the first questions we typically get is when somebody learns about Substrate, Polkadot, Oksama, is when to develop a parachain versus when to develop a smart contract. Personally, I would say, actually, even what is explained here mostly is that it's better to start with ink smart contracts because you now start streamlining with the smart contracts. Then you go on exploring more and more. Maybe if you start with building on Substrate, you're most likely to get discouraged. So this is a good way, and in case you build smart contracts, you can easily deploy them straight away on parachains like Astar, Aleph0, and many more parachains that accept smart contracts. I think Gear also accepts smart contracts. So how it works. Okay, it is a programming language for smart contracts blockchain built with Substrate framework. How does it tie into Substrate? Substrate is a framework for building blockchains. Those can be standalone blockchains or blockchains connected to Kusama or Polkadot, so-called parachains. Substrate contains a number of modules. In Substrate terminology, those are called palettes. Substrate comes with a set of palettes and requirements. So how does Ink come into play here? Ink is a programming language. Specifically, it is an embedded domain specific language. And when you look at Ink, Ink is opinionated to building smart contracts. So it's an EDSL, embedded domain specific language for popularized programming language. So this means that you can use all the normal Rust syntax plus some specifics that we added to make the language suitable for the smart contracts world. How does the palette contract work? Yeah, there is a lot to digest here, but I think this is something that everyone can read through. That's why I'm just going through to see what I should not leave smart contracts as first-class citizens. So there are smart contracts that can be built into your Substrate framework or into your blockchain, and there are rules that you can set for accepting certain smart contracts, because smart contracts are treated as like sort of buggy code, or I can say virus code. So you have to create a situation where yes, smart contracts can be allowed into your blockchain in case you want your blockchain to handle smart contracts. So Star is one of them. We've seen Fala, the Fat family, and Aleph0 T3RN uses palette contracts as a building block to enable multiple. So uses the palette contract. So palette contracts is, I think, is a palette that if you add onto your blockchain, it gives builders the ability to add smart contract capabilities. So use case 2 as a second-class citizens. There's another non-obvious use case for palette contracts, smart contracts as a second-class citizen on an existing chain. By this we mean that the central value proposition of the chain has nothing to do with the smart contract, but it still includes them as add-ons. Okay. Use case 3. Smart contracts as first step into Polkadot or Kusama. Third big use case for palette contracts is to prototype an idea as a proof of concept smart contract before leasing a dedicated parachain slot on Polkadot or Kusama. We shall find out that starting a parachain is an hefty work. You must have at least a proof of concept. You must have done your smart contracts and built some things, because with the parachain you have all these things: marketing, building front ends and back ends, and the smart contracts. So at least smart contracts are very good use case for you to start a proof of concept ideation stage. Okay, versus parachain. One of the first question we typically get is when somebody learns about Substrate, Polkadot or Kusama, is when to develop a parachain versus when to. Distinction here is that in the context of Polkadot and Kusama, a parachain leases a slot for a couple of months for up to 2 years. The deal with the lease that a parachain gets is a fixed slot for executing its business logic and can persist. The distinction to other ecosystem here is that in the context of Polkadot, parachain and smart contracts exist at different layers of the stack. Smart contracts sit on top of parachains. So that question is answered. I think everyone shall read through Ink versus Solidity. You see, they look at the swiftness of Ink. This is also a good read for you to get an overview of the mini blockchains that you have. We have Ink versus Cosmosm for those from the Cosmos ecosystem, and I've read through a lot of these, but as we go on, I want to make sure that I start on the Ink programming at exactly 1920. So I have 2 minutes to test time for Cosmosm development and on-chain testing. WASM can be operated as a local step, single or multiple nodes, or connected to the cliff and so on. So migrating an Ink contract to a parachain runtime. This was also a good read that I went through, because now when you want to migrate to a parachain runtime, you're now shifting from your just a proof of concept to something that is now becoming a real world use case. And yeah, this is where I found terms like runtime engineering and many more things. But our emphasis today is as Prevent can work, the team may consider upgrading to a parachain to unlock the full power of a dedicated app chain. Compared to developing and deploying a smart contract, this requires considerable more time and expertise, which is why we encourage to start with Ink where possible, at least at the prototype stage. Actually, the difficulty in launching a parachain, I think we talked about this, configuring, utilizing existing frame palettes. So yeah, as we are completing, I think our rest, we talked about palettes. If we didn't talk, we can talk about them. Palettes are simply like modules that are programmed to do certain things. For example, if you want to make sure that your blockchain accepts Ink smart contracts, you can just integrate a palette. I think it was called, we saw it here. You can just integrate a palette called palette contracts, I think, and then then you configure it. It can be programmable with smart contracts. Okay, so we are now on getting started, and today we are going to be focusing on this. We are going to set up, create an Ink project, compile, and do some good stuff. So yeah. So in case you are looking for, because must make sure that you've installed that, make sure that you have installed Rust. So once you have installed and you press cargo contract, you will see that you have it installed. Let me open up my terminal. So yeah, if you have cargo contract installed safely, then when you press cargo contract, it must bring certain commands, otherwise to tell you command not found. So please see here installation instruction of the cargo contract. Well, but we can also go for cargo contract. Help. No such command. I've written $T. So cargo contract. So yeah, this shows that my smart contracts are working okay. So everything works. So installing substrate contract node. Now when you're developing a smart contract, when you're starting to develop smart contract, having a node to, then yeah. So the substrate contracts node is a simple substrate blockchain which is configured to include the substrate module for smart contract functionality. The contracts palette, see how it works for more, is a comfortable option if you want to get a quick start. There are two ways for installing the node. This is the recommended way. So you can download the binary. So what I did is I downloaded Ink. So most of the time, since these things take time, so it's around here, since these things take really some good time, I I intend to keep running. Things to do with downloading and installing, most of the time I did it when I'm offline, because sometimes you can just download the template and takes 10 minutes and takes some minutes just downloading. So I'm trying to make sure that you just keep pacing up. But yeah, so to go where my downloaded node is, I think cd documents, cd Polkadot, let's I change into ink, so I want substrate contracts node Linux. So cd directory, substrate contracts node dash Linux. So yes, so this is the way I shift to it. Alternatively, you can do this cargo install. So then we are going to create the ink project. So our aim today is to make sure that we can create at least our first ink smart contract, deploy it, and yeah, try to do something with it, interact with it, what the different parts of your Rust smart contract represent, and ultimately allow ink to do all the magic needed to create substrate compatible WASM bytecode. Use the ink CLI to generate an initial smart contract with some scaffolding code. So make sure you are in a working directory and then run cargo contract new. So as soon as you run cargo contract, so I'm going to just be in ink and run cargo contract. So if everything is installed properly, cargo contract new, and then the smart contract. So the smart contract is flipping. I can call it flipping. Okay, so the smart contract has been created. Now I can go into that cd flipping. So yeah, immediately I go into it. This ink CLI automatically generates the source code contract, which is about the simplest smart contract you can build. You can take sneak peek. So testing your contract. Okay. So maybe at this point we can open VS Code and see the different parts of our smart contract. It's taking quite some time. So yes, this is our the ink smart contract has a same look like a new Rust project. We have the lib.rs. We looked at libraries. So since this is a contract since this is a smart contract, we have the lib. We don't have the main. We have the cargo.toml. We have other things, get ignore. So yeah. We have the mod. So mod is the module, and this pub struct. This shows that these functions are public. So So that means that these functions will be accessed by a user when we deploy our smart contracts. This is an implementation of flipping. This is a method implementing this method, and then inside it we have a function. Yes, I looked at some of these in the Rust sessions last week, but you can also look at these in detail in the Rust Lang book. So we have the constructor again here, and we have the flipper, we have the testing now. This is where testing starts from, #cfg test, and inside we have the individual test modules, mod tests. So we have this as our first test, defined works, and here we have two tests. I think we have looked, so we have also some dependencies in cargo.toml of the scale, package parity scale codec version 3 default, and yeah, it goes up this. So these dependencies help to keep the contract together. We have the lib, name flipping, path, create type, features, and ink as dependency. Okay, so we want to run smart contract. Probably it would be good if you are following through the documentation. So testing your contract, you will see at the bottom of the source code there are simple tests use cases. We have seen those which verify the functionality of the contract. We can quickly test this code is functioning as expected using the off-chain tests environment that Ink provides. In your project folder run, we can run cargo test to test. So control the snake sign or terminal, and then you open up terminal, and we'll bring a terminal for you to test. So you can either test from here or you can test from the other terminal. So cargo test. Blocking, waiting for file lock on build directory. Sometime this is quite some time. As it is running the test, we can keep going through, which you should say successful. So we are waiting for this. Okay, I think probably I can run the test from terminal. One of the things I know about this is that this sometimes takes quite a bit of time. Cargo test. Blocking, waiting for file lock. So I don't know when this blocking will following this blocking will take on. We can continue, compile your contract. So compile your contract, run the following command in your Flipper directory to compile your contract. Cargo contract build. Let me go back and see if I made a mistake. Alright, so as it is building, we can go through this. This command will build the following contract. Build the following for your contract: a WASM binary, a metadata file which contains the contract's ABI, and a .contract file which bundles both. So the .contract file can be used to deploy your contract to a chain. If all goes well, you should see a target folder. Okay, so we are waiting for that, and then see the target folder. So all right, yeah, we are almost there, and let's continue to build. Sorry. Error loading original WASM file, release optimized. So I don't know, maybe we can build again. What could that be? So I think we can rebuild from here. Cargo contract build. Cargo contract build. So I don't know, WASM failed. Post processing WASM file. I don't know what caused this. What I can do is I can go into another smart contract that I downloaded some time back, and then use that one. So cd inc. I'll check that issue later. And let's cd dash dash, or let I go back to inc. So in here I have Flipper, or even I can take Flipper 2, cd Flipper 2. So cargo contract build. Sometimes some errors come due to unstable internet, others but I think this will pass. So this file describes all the interfaces that can be used to interact with your contract. Okay, debugging versus release build. By default, the cargo contract builds the contract in bug mode. This means that the contract will e.g. print statement like inc mv debug. Okay, so the node is console. If debugging was enabled on the node, these ones you can look through. For contracts that are supposed to run in production, you should always build a contract with release. Since we are not in production, I hope this is going to build quick enough. So after this, we are going to run a substrate node, and I think if we can expected an interior send problem. I don't know what this is. 86 out of 148, 97 out of 148. I think, yeah, this is a pretty good internet. Hope the data keeps on. So we are just running cargo contract build to make sure that we build our ink smart contract. Yes, so we've started our smart contract. I really don't know what why this error comes on, but yeah, we can. Oh, I get it could be coming from catch, but yeah, we can go to the next command, which is run a substrate node. So the substrate contract node is a simple substrate blockchain which is configured to include the contracts module. It's a comfortable option if you want to get a quick start. So after successfully installing substrate contract node, you can start a local development chain by running. So when you click on this, you'll be taken to where you can install the substrate contracts node. It's better I just downloaded it and then ran this command. So let me go where it is, and my substrate contract node is in this here. It is this Linux. So in here, or even when I'm here, I can cd .. because this is like your node where which you are going to use to deploy your smart contract. So ls, this is the Linux. So cd substrate contracts node Linux, and then when you're there, you run this command substrate contracts node. Okay, now maybe one of the cause of this error could be that I was running these things and I have cache in my PC. I'll check when I'm offline, but yeah, if not, in the next tutorial tomorrow we shall rectify into it. Substrate contracts node. So substrate contracts node. So when I run substrate contracts node, in the substrate contract node that I deployed, so I've set up a local node in my blockchain, and yeah, so this is going to help me to upload my smart contract. Yeah, not substrate contracts node uses by default the dash dev. So our blockchain has started. You can interact with your node using the contracts UI, and I love this contracts UI. So once you have the web page open, I have to configure UI to connect to the local running node. So click on the drop down, and yes, we are going to connect to our okay, someone okay, I think that is okay. So now when you open this substrate contracts node, it's a UI where you can deploy your smart contracts to okay, it's not increasing, so Control plus, okay, yeah. When you look at it here, we have the testnet, we have Aleph0 testnet, and we have started our local node. So in case you have not started a local node, this substrate contract node will not work. I used to deploy some smart contracts when I haven't started a local node and everything was not working. So make sure that you start a local node, which we have started. This is our local node that we have started. I think one of the errors could be due to internet, because I'm using a lot of bandwidth. But yeah, so with here we can come to add new and then upload a new contract. So we can choose Alice or Bob, but now it is Alice. So our contract give flipping contract was already compiled. Don't know why I'm having that error. It could be because of the bandwidth. But you come to your smart contract, you go to target, you go to ink if you have followed the steps you have been following, or you can go through the documentation, and this file that has .contract is the one that you upload. Flipper to .contract, select. So yeah, in case your node is still running, then you can go to next. This is not good. And click next. So when you click on next, they will show you the binary you're uploading. This binary is the binary in your contract node. If I go to Flipper to ink, target, ink, and then Flipper to .contract. So this is how the .contract file looks like. And it's what we are uploading, because that has the full binary. So to take you here to upload an instance. So when you're uploading the smart contract, you in Substrate, you upload the instance, and then yeah, you interact with the instance of the smart contract. So this shows the gas balance withdrawal. Our smart contract has been uploaded successfully. And here we have execution result okay. So you can try to call the smart contract, and you see that the call is successful. We can flip the smart contract and say get result. So result return type is true. When you look closely in our smart contract, do we still have it? Okay, Control Alt T. I don't know whether computer will be able to handle. In some of the tutorials we shall be using two machines, most especially the Substrate courses, because sometimes you have to run nodes on 2 machines. CD documents. Polkadot. CD ink. Flipper2 and hopefully it is going to open successfully, because okay, it's opening. So this is the ink on the target. So what Flipper does is that it is setting so ink storage we have and most of the time this is, by the way, the smart contract logic. You start with this fg attribute, and then the ink module, the module Flipper2, the module of the smart contract, and the storage. You have a struct there, implementation, and then here we have our ink smart contract is flipping between a false and true. So we start with a value of a billion, and the initial value of a billion is always false. So in case you write to the smart contract, you change the state to true for pub fn flip. So this is a mutable storage. That means that the value can be changed, can be altered. So here we are altering that when you call the smart contract, when you write to the state of the smart contract, you change the value from the false to true. And this is a public function, so this public function will be accessed by the user. That's why we are able to access this. We also have a get function, which is a public function that we can be able to access, and this will help us to read the value of the smart contract. These others are tests, and I think now you can clearly get. So when you say get, it will only bring the true value here, but if I call the flip function, which is responsible for changing the state, and I say call contract, I'll look up here is that is the contract is signed, and there is some gas fee. And if now I call the get contract, our return value has turned to false. So this is the way we are accessing and executing our smart contract. Okay, we are 10 minutes to time. This has been a good run of the smart contract. So yes, and now deploying the smart contract, we have deploy the smart contract using the contracts UI. So you can also that's the first method we've used. You can also deploy your smart contract using another method, which is the CLI, command line interface. You're using cargo contract, so you can say cargo contract build, cargo contract upload, sorry Alice, and cargo contract instantiate, sorry Alice. So yeah, I think I think one of the reasons to why the contracts didn't build is I might have catch, because I was doing this pre the tutorial. Yeah, I might have this catch in my terminal. So calling the smart contract, we have also seen that RPC versus transaction. There are two ways for calling: dry run via RPC remote procedure call, of external program, for example browser or front-end application to communicate with the substrate node. We are still running our node. So yeah, there are some troubleshootings here, and hopefully I will find one of the reasons why I have this issue, since I've not yet I've never experienced it. But yeah, so today, as we start our Ink smart contract series, I think that has been all, and in case there are questions,